So you do need a calculator. So parametric equations allow you to represent two related motions with respect to time. So we're describing movement along a curve. So you'll have two functions, your x function in respect to time and your y function in respect to time. So let's look at example 1. So notice that it says that the interval is -2 to +2. And that's why I created this little T-chart, 3 columns. So go ahead and make a rough little T-chart. And we're using the 5 numbers between -2 and +2. So from -2 to +2. So -2 to +2, you're going to take these 5 numbers and substitute it into your x of t function. So with your calculator, take 3 times -2 squared and get these 5 numbers. So take these 5 numbers, substitute it into your x function. So figure out what you get when you take 3 times -2 squared. So because you're my second class of the day, I already know the mistakes that you might make. Well, this one, it doesn't really apply. But you do want to make sure anytime you put a negative in your calculator that you put parentheses around it. So use your calculator to get those 5 numbers. So if you take 3 times -2 squared, your first number should be 12. 3 times -1 squared, that should be 3. Go ahead and fill in the rest. All right, who got that for their 5 numbers? All right, so now we're going to use our second function. Going back to these original 5 numbers, which is -2 to +2. Substitute these 5 numbers into your y function. So take 2 times -2, 2 times -1, 2 times 0, 2 times 1, and 2 times 2. So now when you graph, we eliminate the t variable, and you're only graphing x and y. So this is what we need to graph. Now notice that your graph is not scaled, so you determine how you want to scale it, what you want to count by. So I'm noticing that for this particular curve, my x value, I don't have any negative x value, so it doesn't make sense for me to just put it down the middle. I'm going to put my my y-axis kind of close to the edge because I don't need any negative x values. So let's go ahead and start marking that up. But you can honestly decide when you're taking your test, because when you take your test and your skills check, it's not labeled. You decide how you want to scale it. There's really no wrong way to scale your graph. So I made mine super thick because I want you all to see it. And then I am going to scale my y-axis. I need to go up to 4 and -4. So I'm going to count like every third line. I'm going to make 1. And I probably could have, did that even a little bit more spread out. But you decide how you want to scale your graph. So what I did was I counted every 2 or 3. And then on my x-axis, I counted by 2s. But again, you decide how you want to scale your graph. Go ahead and plot your points. There really is no wrong way to scale it. So your curve should look like a sideways parabola. Notice I'm not putting arrows at the end of the curve because we're only going from -2 to +2. And then the last thing you want to do, so when I said that we don't add arrows, I meant we don't put arrows at the end. So like I'm not going to put arrows to show, like that's not what we don't add arrows. But you do show arrows to show direction. So the first point on my curve was 12, -4, so that would be here. And then I moved along, I'm going this direction. So the curve is traveling in this motion. So I do need to add arrows on the curve to show that it's going this direction. So it's going this direction. and then it rounds the curve. So that is the direction of the curve, the orientation of the curve. Because it's starting here, the curve is traveling in this direction. So my first point from my interval, which was -2, so the point that represents t equals -2 is here. And then the curve is going this direction. This is t equals -1, this is t equals 0, t equals 1, t equals 2. And that is how you graph a curve, a parametric curve. So for example 2, we're going from -3 to +3. Go ahead and make your t-chart. So notice that the interval of time, or t, is -3 to 3. So I'm looking for 14 numbers. So take these 7 numbers, substitute it into x, and then take the same 7 numbers and substitute them into y. So this is the one I was thinking of. Because it says t squared minus 4, if you type in your calculator -3 squared minus 4, you're not going to get the right answer. So what do you need to include in this? You have to include parentheses. So go ahead and find your 14 numbers. So you need to figure out your 14 numbers before you can set up your graph. So again, this says t is -3 to 3, so that's my interval, -3 to 3. So I made my t-chart. T is -3 to 3. Take these 7 numbers, substitute it into your x function, and then take the same 17 numbers. I keep saying 17 numbers. The same 7 numbers and substitute it into your y function. So take a minute to get those 14 numbers, and then we will graph them. So I'm noticing that my x values, I need to go all the way back to -4. So when I put down my y-axis, I'm going to put it a little closer to the middle. So I counted, because I knew I had to go up to -2 and +2. I just decided to scale it because I knew, I knew I had to go to -1.5 and +1.5. I decided to count by halves. So that's just easier for me to graph. So on my y-axis, I'm counting by halves. On my x-axis, I'm counting by ones. You go ahead and draw your curve. And then add your arrows to show the direction of motion. So my first point is at +5, -1.5. So my curve is traveling this direction. So this represents t equals -3, and this represents t equals -2. So I'm just going to add arrows to show that motion is going this direction. And you don't need to put a lot of arrows on there, just a few. And that is your curve. It is simple. That's it. All right, let's go ahead and make a little T-chart. So now we are graphing from 0 to 360, and I just counted by 90s. So I'll help you fill this out. So go ahead and make your T-chart. And if you want to, I know we don't really like radians, you can also put it in degrees. For theta. So you can decide how you want to put that. So do you remember, and I guess if you really want to use your calculator, you could too. You could just type in cosine of 0 degrees. But that kind of is sad, though. Does anybody remember the cosine of 0 degrees? So at 0 degrees, what's the x value? 1. So the order pair for 0 degrees is 1, 0, sorry. So the cosine of 0 degrees is 1, and the sine of 0 degrees is 0. If you rotate up to 90 degrees, the cosine is 0, and the sine is 1. At 180 degrees, the cosine is -1, and the sine is 0. At 270 degrees, the cosine is 0, and the sine is -1. And now we're back here. What do you think this graph is going to look like? A circle. Go ahead and graph it out. And the range of motion, you're starting here. And so we're going this direction. So your graph is actually a little bit better. I didn't use the same graph that I put in the notes. The graph that I have up here is stretched out a little bit, which is why mine doesn't look like a perfect circle. But your graph is a lot better. So yours should look like a perfect circle. Graphing a curve. And our last example for today is going to be to write an equation for a curve, including the domain restriction. So I'm going to give you the steps to write your equation for your curve. So when you're writing a parametric equation, and there's a lot of ways, it's also called a Cartesian or rectangular equation. There's a couple different ways that it is described. So your 3 steps, step number 1 is going to be to solve for t. Solve a parameter for t. Solve for parameter t. So let's go ahead and do that. I'm going to use the x equation. So x equals t squared minus 4. Go ahead and solve that for t. So what would be my 2 steps to solve this equation for t? But what I need to do first to get rid of that minus 4. All right, so let's add 4 to x. And then we take the square root. So that would give us, when you take the square root, plus and minus the square root of x plus 4 equals t. So our second step, step number 2, is to substitute. The value in for t in the second equation. So I'm going to take this and substitute it in my second equation where there's a t. So I'm going to take this and put it here. So that gives me y equals plus or minus the square root of x plus 4 all over 2. So what I just did was I took my parameter that I solved for t and I substituted into my second equation for t. So I swapped the yellow for the yellow. And the last step is going to be to solve for y. And write domain. So in this parameter, y is already solved for because it already says y equals. So all we need to do is write the domain. So remember, you cannot take the square root of a negative. So to find your domain, you would take what's under the square root, set that greater than or equal to 0. So that means your domain is greater than or equal to -4. So my domain is -4 to infinity. So my domain is -4 to infinity. And that is my final answer. So we're not graphing this one. We actually graphed it. If you go back to example 1. No, actually this was example 2. So if you look at example 2, we already graphed the curve. So what we did now was we wrote an equation for that curve. So that graph that you graphed for example 2, this is the equation for that graph. And that's the domain for the graph. Okay, we're going to end there because we don't have enough time to actually finish the second one. Again, I will update Canvas today with the last 3 homeworks. 18, 19, and 20 are all worksheets. So I'll put the due dates, the test dates, and all that up on Canvas a little later today.